Today we are going to do section 10.2, which is to graph quadratic equations. We are graphing ax squared plus bx plus c. A is our leading coefficient, b is the number in front of x, and c is our constant. To know whether your parabola opens up or opens down, you can just look at the leading coefficient, a. If that leading coefficient is a positive number, then your parabola opens up. A is greater than 0. If your leading coefficient is a negative number, your parabola opens down. A is less than 0. It is literally just looking at the leading coefficient to know whether your parabola opens up or down. A positive leading coefficient opens up, a negative leading coefficient opens down. Next, we're going to look at the axis of symmetry. The axis of symmetry is this imaginary line that goes down the center of your parabola. And that axis of symmetry is a vertical line. It can be found by the equation x equals negative b over 2a. And it will be an x equals a number equation. That's the equation of a vertical line. That imaginary line does divide the parabola into two equal portions. They are mirror images of each other. Let's find the axis of symmetry for this equation, y equals 3x squared plus 12x minus 8. We're going to start out with x is equal to negative b over 2a, which is our formula to find the axis of symmetry. So you're going to have x equals negative b. Well, b itself is 12. So a negative b means that we are going to have a negative 12 over 2 times a, and a in this case, of course, is our leading coefficient, so we're going to substitute a 3 in for our a. That means that we have x equals negative 12 divided by 6. X is equal to negative 2. This is our axis of symmetry. Notice that it is a vertical line equation. X equals negative 2 solves our problem for the axis of symmetry. We're next going to find the vertex of our equation. Notice I kept the exact same equation that we had before. And the vertex is an xy pair that will be on the end of our parabola. And since this parabola opens up, we know that we have our parabola opening up. We're going to have a vertex down here at the very bottom of our parabola, and that's an xy pair that we have to find. We know from our last page that x is equal to a negative 2. I believe it's negative 2. Yes, it is. So we've got x equals negative 2. That is the x coordinate of our vertex. And now we're going to use that number to find the y coordinate of our vertex. So y equals 3 times the negative 2 squared plus 12 times the negative 2 minus 8. Use your order of operations. So we have 3 times 4 minus 24 minus 8. That gives us 12 minus 24 minus 8, which is a negative 12 minus 8. So it tells us y is equal to a negative 20. So our y coordinate of our vertex is a negative 20, and both the x and the y as an xy pair is our vertex. We now know that our vertex is at the point negative 2, negative 20. Let's go ahead and find the axis of symmetry and the vertex for this different equation. Which way does this parabola open, by the way? Because our leading coefficient is positive, we know that this parabola is going to open upward. Cool. That's just an extra little bonus to know. You'll have to know that for some of your homework. Finding that axis of symmetry, again, x equals negative b over 2 times a. So I have x equals positive 8 this time, because my b is a negative 8, so the opposite of that is a positive 8, over 2 times 2, so that gives us x equals 8 divided by 4, which tells us that x is equal to a positive 2. There is our axis of symmetry to begin with. The vertex, remember we have our x-coordinate already for our vertex because we have the axis of symmetry, but now we have to find the y-coordinate. So y equals 2 times 2 squared minus 8 times 2 plus 7. So that's 8 minus 16 plus 7, negative 8 plus 7 tells us that y is a negative 1. So our vertex is 2 comma negative 1. Now the next thing that we want to do is we want to find 2 more points on each side of the vertex. Please notice I've drawn an xy coordinate pair table down here. I'm going to put x and y horizontally on here. I'm going to also label this as the vertex. And I will substitute 2 and negative 1 in for our vertex there. I want to choose 2 more points on each side of the vertex. Think of that top layer of the XY table as your x-axis. I have the number 2. 1 unit to the right of 2 is 3 on the x-axis. 1 unit to the left of 2 is 1 on the x-axis. So I can substitute the 1 in. I'm going to have 2 times 1 squared minus 8 times 1 plus 7. So it gives me 2 minus 8 plus 7, negative 6 plus 7 gives me a positive 1. So I know I can put a positive 1 in there. Then we have 2 times 3 squared minus 8 times 3 plus 7. So I have 2 times 9 minus 24 plus 7. That's 18 minus 24 plus 7. That's a negative 6 plus 7. And that also is a positive 1. Please notice that this y value and this y value are exactly the same. That is because we went up 1 unit this way and 1 unit to the left this way. The x's are equidistant from the vertex, so their y's should be the same. That's a great way of checking to see that you have the right numbers. Then we need to choose another set of xy pairs. Perhaps we could go up to 4, go in this direction, so 1 more unit up. 1 more unit down puts us in 0 for x. That 0 is a pretty easy number to work with. 2 times 0 squared minus 8 times 0 plus 7 gives us 7 as our answer. And if you notice, please, C up here is the y-intercept on your graph. You will always have C as your y-intercept. So if we just want to check ourselves in regards to that 4 now to make sure that we've really got our vertex in the right spot, we'll have 2 times 16 minus 32 plus 7. So that's 32 minus 32 plus 7, or 0 plus 7. Obviously, we've got our 7 here. And again, those 2 xy pairs, the y's should be the same because they're equidistant for the x's from the vertex. Now, the next thing that we would do once we have our xy table is to graph this. So we're sitting at 2, negative 1 for our vertex down here. Then we had 1, 1, we had 3, 1, and then remember our y-intercept was at 7. So 1, 2, 3, 4, 5, 6, 7, 0, 7, and at 4, 7. Now I have my vertex. I have 2 points on each side, and I'm going to draw my parabola through those points. It's not going to be anything too fancy, but it's not a straight line. It is a curve. It does open upward. Please make sure you have a vertex and 2 points on each side of the vertex. Make sure I can see the dots as you are graphing that. The next thing that we're going to talk about is minimum and maximum values. Minimum and maximum values are actually the y-coordinate of the vertex. You know how the axis of symmetry was the x-coordinate of the vertex? It plays 2 roles. Well, minimum and maximum values are the y-coordinate of the vertex. So this number also plays 2 roles. The lowest point, the minimum, is how far down on the y do we have to go. So I don't care what the x is here in terms of my answer. I need the x to find my y, but my y is going to be my minimum point. Whereas the highest point is my max. So it's how far up I'm going for that y, how very top of my parabola. Notice that the minimum, the parabola opens up, so that would be our positive leading coefficient, will give us a minimum value. And the maximum is where the parabola opens down, and that would be our negative leading coefficient, so that y is going to be at the very top. Let's find out whether this has a min or a max, and then find the value. The first thing is, let's decide whether this is a min or a max. Look at that leading coefficient. That leading coefficient tells you open upward. So that means that we are looking for a minimum on this problem. So the very first thing we have to find is our x. So negative b over 2 times a. So x equals positive 16 over 2 times 2. So that gives us an x equal to 4. Fabulous. Now we're going to substitute the 4 in for our x. And when we do so, we can write that equal to f of x, or you guys know that f of x is the same thing as y. So I can write y equals there. So I have y equals 2 times 16 minus 64 plus 4. Y is equal to 32 minus 64 plus 4. Y is equal to negative 32 plus 4. And y is equal to negative 28. Okay, I found the y-coordinate of my vertex. That y-coordinate is my min or max. We said this was a minimum, so we're going to write min equals negative 28. Put a box around that answer. We don't want x equal 4 as part of our answer, but it is part of the process to find out what the minimum is. And in this case, the minimum was 28. Please make sure you're showing your work. If you want to work through these problems out of the textbook online, please feel free to do so. These first 2 deal with finding the vertex and finding the axis of symmetry. And the next 2 deal with minimum and maximum. And the last one is a graphing problem where you have to graph the parabola. So you can stop the video right here and you can go to page 638 and do those problems. I will keep going here and I will show you what the answers are so that you can check yourself. Here are the answers to the first 2 problems, the axis of symmetry and then the vertex for both 4 and 5. Numbers 29 and 30, it tells you whether it's a min or a max value and what that value is. And the last one is a graphing problem. Here's what your graph should look like. Please make sure that I can see the dots when you are graphing your points so that I have your vertex and 2 points on each side. Good luck. luck with your problems. If you have any questions, please make sure you stop in and see me. Thank you.